Everything is moving. Our planet spins and it orbits the Sun. The Sun itself orbits the center of our galaxy, the Milky Way. But this is all motion relative to something else. How do we measure our speed against the entire universe itself? Is there a background, a final, ultimate reference point to tell us where we are truly going? The answer is yes, and it is the oldest light in existence. It's called the cosmic microwave background, or CMB for short. Imagine the entire universe, just after it was born, was filled with a super-hot, brilliant light. As the universe expanded and cooled over 13.8 billion years, that light stretched out and cooled down with it. Today, that ancient light is still everywhere. It fills all of space, a faint, cold glow that our instruments can see in every direction we look. This isn't just any light. It's the afterglow of creation, a snapshot of the universe when it was only 380,000 years old, and it is almost perfectly uniform. The temperature of this light is the same everywhere, to an astonishing degree of precision. It is the ultimate cosmic backdrop, a stationary canvas against which all motion in the universe can be measured. And when we measure it, we find something incredible. The light from one direction of the sky is a tiny bit warmer, and the light from the opposite direction is a tiny bit cooler. This isn't a flaw in the background. It's proof of our own movement. We are moving towards the warmer part, causing the light waves to bunch up slightly. We are moving away from the cooler part, causing them to stretch out. This tells us our speed and our direction relative to the fabric of the cosmos itself. But here is where the mystery truly begins. It's not just our galaxy, the Milky Way, that is on this journey. We are part of a small cluster of galaxies called the Local Group. Our giant neighbor, the Andromeda Galaxy, along with dozens of smaller galaxies, are all traveling right alongside us. We are all bound together by gravity, a single cosmic family on an enormous voyage. Imagine a great fleet of ships all sailing together across a vast, dark ocean. They are not just drifting randomly. Every single ship, from the largest to the smallest, is moving in the same direction, at the same incredible speed of over 2 million kilometers per hour. This shared fate tells us that whatever is pulling us is not small or close. It is something immense, something with a gravitational pull so powerful it can command the movement of an entire group of galaxies at once. To find out what it was, astronomers in the 1970s and 1980s began an ambitious project. They started to map the movements of thousands of other galaxies, far beyond our own local group. They measured how fast these distant galaxies were moving away from us, expecting to see the simple, uniform expansion of the universe. They were looking for the normal, expected pattern of cosmic motion. What they found was anything but normal. They discovered that huge collections of galaxies, structures called superclusters, were also moving. They weren't just expanding away from each other, they were flowing. Great rivers of galaxies, hundreds of millions of light-years long, were all streaming in the same general direction. Our own local group was just one small part of this massive collective motion, a cosmic flow on an unimaginable scale. But there was a problem, a huge obstacle in the investigation. When astronomers tried to look in the direction that all these galaxies were flowing towards, their view was blocked. The source of this immense gravitational pull, the very destination of our cosmic journey, seemed to be hidden behind a thick curtain in the sky. This curtain has a name: the Zone of Avoidance. It isn't a physical wall in space, but a wall made of our own home. It is the bright, dense plane of the Milky Way galaxy itself. When we look towards it, we see a thick band of countless stars, glowing clouds of gas, and dark, obscuring lanes of dust. This cosmic fog in our own backyard is so thick that it completely hides our view of the deep, distant universe that lies beyond it, precisely where the great mystery lies. So how do you map something you cannot see? How do you chart a course when a giant curtain is drawn across your view? Astronomers realized they had to look at the universe with different kinds of eyes, not eyes that see visible light, the light we see, but eyes that can see other forms of energy, other colors of the cosmos that our eyes are not built for. The solution was to use telescopes that detect wavelengths of light that can pass right through all that dust and gas, almost as if it weren't there. Think of infrared light, which we feel as heat, and radio waves, which carry signals for our radios. These forms of light have longer wavelengths, allowing them to navigate the crowded lanes of our galaxy and reach us from the other side, carrying secrets from the universe beyond. And so, with these new eyes, projects like the 2-micron all-sky survey, or 2MASS, began the slow, patient work of peering through the veil. They weren't looking for single, spectacular objects. They were building a cosmic census, painstakingly measuring the position and motion of every single galaxy they could detect, one by one, creating a map of what was once a total blank. And as this new map took shape, the first major suspect in our cosmic mystery came into view. It was immense, a colossal structure called the Virgo Supercluster. This isn't just a small family of galaxies. It's a sprawling city of them, containing over 1,000 galaxies, including our own local group, spread across 110 million light-years. We realized we live on the outskirts of this magnificent cosmic city, and just like streams flowing towards a great river, our local group is indeed falling towards its dense and massive center, a region called the Virgo cluster. For a time, this seemed to be the answer. Of course we're moving. We're being pulled in by the gravity of our home supercluster. The case seemed closed. But it wasn't. When scientists did the math, the pull from the Virgo supercluster alone wasn't enough. It could explain some of our motion, but not all of it. We were moving too fast. There had to be something else, something even more massive, lurking further away, its immense gravity reaching across the void to pull on us, on Virgo, on everything. This is when they found it. The Great Attractor. Now, that name sounds like it comes from a storybook, but it describes something very real, though very strange. The Great Attractor is not a single object. It's not one giant galaxy or a supermassive black hole. It is what scientists call a gravitational anomaly. That's a simple way of saying it's a region of space where there is a huge, unexplained concentration of mass, pulling everything towards it. Imagine the mass of tens of thousands of galaxies like our Milky Way, all concentrated in one area of space, about 250 million light-years from us. This is the Great Attractor. It creates a kind of gravitational valley in space-time, and our entire region of the universe, including the whole Virgo supercluster, is flowing towards it. But the story of our cosmic journey does not end there. In science, every new answer often reveals an even deeper, more profound question. The Great Attractor was a monumental discovery, but as astronomers mapped the flows of galaxies on an even grander scale, they noticed something astonishing. The Great Attractor, this titan of gravity that pulls on thousands of galaxies, is itself being pulled somewhere else. This colossal river of galaxies we found ourselves in was just a tributary, flowing into an even larger, more powerful cosmic current. The mystery wasn't solved. It had just expanded to a scale we had never imagined before. But then, in 2014, our understanding of our cosmic neighborhood shifted dramatically, revealing something truly breathtaking. Scientists unveiled a new definition for our galactic home, a structure so vast and magnificent, they named it Laniakea. This beautiful Hawaiian word means immeasurable heaven, and it perfectly captures the sheer scale of this discovery. No longer do we think of superclusters as just simple scattered blobs of galaxies. Instead, imagine a giant cosmic river system where galaxies, like tiny boats, flow along invisible currents. Laniakea is a watershed of gravity, a massive region where all the galaxies within it are being drawn towards a common gravitational center, much like water flowing down a mountain into a shared valley. And what a river system it is! Our Laniakea Supercluster stretches an astonishing 520 million light-years across. To put that into perspective, if you could travel at the speed of light, it would take you over 500 million years just to cross it. This is our true home, a sprawling, grand tapestry of galaxies, all interconnected by the invisible threads of gravity. This profound revelation fundamentally changes our cosmic address. For so long, we thought our neighborhood ended with the Virgo supercluster. But now we know our true place in the universe is far grander, far more interconnected. Your cosmic address isn't just Earth within the solar system, inside the Milky Way galaxy. It's Earth in the solar system, a part of the Milky Way, which is itself a member of the local group, all nestled within the magnificent Laniakea Supercluster. Think of it. This incredible understanding of our true home is incredibly recent, a discovery less than a decade old, a testament to our ever-evolving quest to map the cosmos. Now, you might be wondering, if all these galaxies in Laniakea are flowing together, does that mean we're all destined to crash into the Great Attractor? It's a natural question, but here's the ultimate plot twist, a mind-bending piece of the puzzle. The answer is no. While gravity is indeed pulling us together on a local scale, drawing galaxies within Laniakea towards its densest regions, there's another, more dominant force at play on the grandest scales of the universe. This force is dark energy, and it's actively causing the very fabric of space itself to expand, pushing galaxies apart. So, while we've mapped our cosmic river, charting the gravitational flows within Laniakea, the story of cosmic motion is far from over. What lies beyond the boundaries of our supercluster? Are there even larger structures, even grander flows? Some scientists have even detected hints of a mysterious dark flow, an unexplained motion of galaxy clusters on scales even larger than Laniakea, pulling them towards something entirely unseen, far outside our observable universe. The universe is not a static collection of stars. It is a dynamic, breathtaking expanse, constantly revealing new layers of its immense complexity. So this grand cosmic story doesn't have a simple ending. We are caught in a magnificent flowing river of galaxies, a current shaped by things we can see, and more importantly, by the immense, invisible presence of gravity from matter we can't. It's a cosmic ballet where our local group is pulled by the Virgo Supercluster, which is itself being drawn toward the Great Attractor, all while being pushed from behind by a vast empty region called the dipole repeller. And isn't that just incredible? To realize that our entire existence is part of this silent, colossal migration across the universe. We are passengers on a ship made of a galaxy, sailing on cosmic tides we are only just beginning to map. Our journey has a direction, but the final destination remains a beautiful, tantalizing mystery written in the fabric of space-time itself. To solve this, we are building new eyes to see the universe. Future telescopes, both on Earth and in space, will be able to measure the positions and velocities of millions upon millions of galaxies with breathtaking accuracy. They will peer even deeper through the zone of avoidance, using different wavelengths of light, like infrared and radio waves, that can pass through the dust and gas of the Milky Way. With these new maps, we hope to see the full extent of Laniakea and perhaps discover even larger structures to which it belongs. We are charting the great cosmic continents and oceans, and we may find that what we thought was a shoreline is just the beginning of an even vaster territory. Every new galaxy we place on the map helps refine our path and tells us more about the forces guiding us. And at the heart of this gravitational puzzle is the universe's greatest enigma, dark matter. It is the invisible skeleton of the cosmos. The Great Attractor and the immense filaments connecting superclusters are made mostly of this mysterious substance. It doesn't shine or reflect light, but its gravitational influence is the engine driving our cosmic motion. Think of it this way. The galaxies we see are like bright foam on the surface of a deep, unseen ocean. It's the currents within that invisible ocean of dark matter that are truly steering our course. Understanding our journey across the universe is therefore deeply connected to understanding the fundamental nature of this invisible matter that dominates the cosmos. And here is the most profound part. This journey isn't something happening far away, to distant objects. It is happening to you, right now. You are moving at over 2 million kilometers per hour toward a place you've never seen, as part of a galaxy in a supercluster adrift on the largest known currents in the universe. This motion connects every one of us to the grandest story of all. The iron in your blood, the calcium in your bones, these elements were forged in stars that lived and died within this Milky Way, this galaxy that is our home and our vessel on this incredible voyage. We are, in the most literal sense, children of the cosmos, participating in its unfolding destiny. So, when we study this motion, we are doing more than just cosmic cartography, more than just mapping where we are going. We are piecing together the complete history of the universe. We are learning how the tiny fluctuations in the moments after the Big Bang grew into the magnificent web-like structure we see today. And the quest continues. Every new discovery, every solved piece of the puzzle, only reveals a deeper, more beautiful, and more complex universe than we ever imagined. The final answer to "where are we going?" might not be a simple place, but a deeper understanding of the laws that govern everything. And that is a destination worth traveling toward.